morning students. This is Conductance Higher Secondary School, Barigula, Moilwans. I am here lecturing chemistry. So last class we have discussed about the third chapter of your class 12, that is electrochemistry, and last class was the very interesting and the introduction class of the chemistry, that is electrochemistry. Today I am going to discuss about the second lecture, that is redox reaction. At first I have to remind it that last class was the very interesting thing, that is what is the branch of chemistry like electrochemistry, and the topic by which I can understand that what is electrochemistry. At first, what is the definition of electrochemistry? That means what is electrochemistry means electrochemistry, who is the chemistry which is related with the electric current, that is called electrochemistry, or it is the branch of chemistry which deals with the study of the interrelationship between the electrochemical cell and the electrolytic cell, that is called electrochemistry. That means the transformation of electrical energy into chemical energy and the chemical energy into electrical energy. So today I am going to discuss about the redox reaction. At first you have to know that, my dear student, what is redox reaction. So redox reaction means the reaction which is carried out with simultaneous time both reduction and oxidation reaction. So it is reduction and the oxidation. So the reaction which is involved with the reaction occurring oxidation and reduction at simultaneous time, then it is called redox reaction. So what do you mean by reduction reaction and what do you mean by oxidation reaction? There are two concepts. One is known as old concept, another is known as modern concept or new concept. So according to the old concept, we know reduction reaction, that means the addition of hydrogen is called the reduction reaction. Like that, the removal of hydrogen is the oxidation reaction. Like that, the addition of oxygen is called oxidation reaction, and the removal of oxygen is called the reduction reaction. That was the old concept of in your first year or chemistry, that is class 11, which have already read. Now the modern concept, that is new concept, is raised. Like that, the gaining of electron or the transformation of electron from one substance to another substance is called reduction reaction or redox reaction. Sorry, it's called redox reaction. That means the redox reaction means the transference of electron from one substance to another substance. That is called redox reaction. So, my dear students, that is reduction reaction. In case of reduction reaction, that is the modern concept, we know the gaining of electron is called the gaining of electron by any atom which means that is called reduction reaction, or the loss of electron by any atom or group of atom is called the oxidation reaction. So in case of reduction reaction, the gaining of electron is called reduction reaction, and loss of electron is called oxidation reaction. That is reduction reaction, that is oxidation reaction. So now by the examples like gaining of electron. Suppose chlorine. Here is chlorine plus of one electron. So when any atom gain electron, the charge will be negative because of electron is negative in charge. So Cl minus 1. So this reaction is called reduction reaction. That means the accept of electron or gaining of electron of chlorine atom, by which the chlorine minus ion, that is chloride ion, will be formed. That is called reduction reaction. Now the oxidation reaction, that is suppose Na minus of electron, one electron, that is formed Na plus. That means when the oxidation reaction or oxidation takes place in a reaction, then the metal atom lose their electron and getting positive charge over it, due to which the cation will be formed, and here will be the anion will be formed by the gaining of electron, and that type of reaction is called reduction reaction, and that type of reaction is called oxidation reaction. So now we are going to discuss about the reduction reaction. That means at simultaneous time both reduction reaction and oxidation reaction taking place. So the examples of redox reaction, suppose Na plus half Cl2, that is chlorine molecule. So Na plus half Cl2 will be formed, that is Na plus Cl minus, or compound like NaCl. So in that case the sodium metal lose their electron to getting Na plus ion, and chlorine, that is gain of electron, that is called chloride ion, due to which Na plus Cl minus is formed, and the compound will be NaCl like table salt, which is, you have already known that table salt, or what is table salt. So in that reaction we know the redox reaction will be taking place. So my dear students, then the concept of redox reaction, very important, and it is a redox reaction. So in a simple manner I can discuss. Suppose Zn solid plus Cu2 plus, that is aqueous, which is formed Zn2 plus aqueous and Cu solid. In that reaction the copper will be formed, the copper metal, and the zinc metal form the zinc ion. So in case of loss of electron, there will be taking place between zinc metal and zinc ion. Here is loss of electron. That means there will be the oxidation reaction taking place. So where oxidation takes place, or oxidation reaction takes place. But in that case there is gain of electron. So the reduction reaction taking place. That is very important concept. So in case of loss of electron, that means metal undergo the loss of electron, that is 2 electron, to form the zinc 2 plus ion, and the copper 2 plus ion will be gain of electron or gaining electron, that is 2 electron, to form the copper metal. So this reaction is also known as a redox reaction. Okay. Now I am going to discuss about the next term, that is electrolytic resistance and conductance. So electrolytic resistance and conductance. electrolytic resistance and conductance. So electrolytic resistance and conductance. At first we have to discuss, or we have to know, what is Ohm's law. What is Ohm's law? On the basis of the electric current or the electrochemistry, Ohm's is a scientist that has given a law that is called Ohm's law. That means it states that, or Ohm's law that states that the strength of the conductor or strength of the current passing through a conductor is directly proportional to the potential difference across it and inversely proportional to the resistance. That means it states that the strength of current, that is I, strength of current passing through the conductor is directly proportional to the potential difference across it. So potential difference denoted as, that is V. Now I is directly proportional to V, where V is the potential difference in volt and I is the current in ampere. So now we can discuss the V is directly proportional or I is directly proportional to V. That means V is equal to IR. R is a proportional constant which is known as the resistance. It is also called resistance. So I is equal to V by R. Now the electric current, that is the strength of the current, is directly proportional to the potential difference and inversely proportional to the resistance. That means if the resistance will be more, then the strength of the conductor will be less. So I is equal to V by R. That is the Ohm's law. Now the unit of I, or unit of that is resistance. Unit of resistance I can say there. So here R equal to V by I. So that is called resistance. Resistance means the opposition force which is offered by any substance through the opposite direction of the flow of current. ता माने कोन होसी ना जो तुमरो इलेक्ट्रिक करंट फ्लो करूसी, इलेक्ट्रिक करंट जो हमर कंडक्टर रे फ्लो करूसी, जे opposition force मिलुची, that is called resistance. That means the resistance means the opposition offered giving towards the flow of electric current, that is called the resistance. So the unit of resistance, potential difference is the volt and current in ampere, that is ampere. So that is called ohm. Or symbolically it is represented by that symbol. So the resistance is represented in the unit, that is ohm. Now I am going to discuss about the conductance. So conductance, that is denoted as C. Now the conductor is, or the conductance is the reciprocal of resistance. Conductance is the reciprocal of resistance. That means C is inversely proportional to the R. The conductor is reciprocal of the resistance. Conductance. So C is equal to, that is 1 by R, that is rho into 1 by R. Now the resistance again, resistance or again the resistance is directly proportional to the length of conductor and the resistance is inversely proportional to the area of cross section. That is, if one electrolyte is taken in a box, that means the electrolytic resistance will be directly proportional to the length of conductor and inversely proportional to the area of cross section. Now, the combining both, then we will get the R is directly proportional to L by A, or R is equal to rho L by A. So I cannot here write that. Now resistance is equal to rho L by A. Here is the resistance, the length of conductor, A is area of cross section, and that is called rho, which is known as specific resistance. Specific resistance. Specific resistance. Again, if L equal to 1 centimeter and A equal to 1 centimeter square, then R equal to rho. R is equal to rho. That means the resistance is equal to the specific resistance when 1 centimeter of length of conductor and 1 centimeter square of area of cross section is here. So the current carrying conductor containing 1 centimeter in length and area of cross section, that is 1 centimeter, then the specific resistance will be equal to the resistance. Again, the conductance is known as the reciprocal of resistance. So in that case, the conductance is directly proportional to 1 by, that is rho L by A. Now conductance is equal to, suppose conductance is equal to, or it is directly proportional, that means C is equal to, and here will be C is equal to 1 by rho into A by L. So C is equal to 1 by rho, that is kappa into A by L. So it is called specific conductance, or it is also known as conductivity, where kappa is known as specific conductance, or conductivity. So, and A by L, that is A by L is known as cell constant. It is also known as cell constant. So the relation between the cell constant and the conductance will be written as, the conductance is equal to, the specific conductance into cell constant. So that relation or that formula should be very, very important for you students. Now I am going to discuss about the specific conductance. Here will be specific conductance and A by L, that is the cell constant. So what is the unit of conductance? We know that the conductance is the reciprocal of resistance. That means resistance, we know the resistance unit, or the unit of the resistance, that is ohm, and the symbolically represent that. Now the conductance, the unit of conductance will be 1 by ohm, that is known as mho. The reverse of ohm, that is called mho, or the ohm inverse. Is the unit of conductance. So my dear students, today's class was the first or second class, that is resistance and conductance and the redox reaction. So thank you my dear students. Next class we have discussed about the next part, that is molar conductance and equivalent conductance, and also I am going to discuss about in the next class, that is Polar's law, which is very important in your class 12 electrochemistry. So thank you.